Okay, question 2. A rigid body rotates to about a fixed axis through a point in the body with uniform angular velocity of 600 revolution per minute. So the velocity then decreases at a constant retardation to 300 rpm in 6 seconds. So we have to determine the angular acceleration, the number of revolutions the body has turned through in 6 seconds, and then lastly, the extra time needed by the body to come to a stop if it continues to slow down at the same rate. Okay, so I'm gonna do it here. Now, the information that we have is the initial angular velocity. I think this is too big. Okay, so initial angular velocity, which is given as 600 revolution per minute. So we have to convert this into radian per second, which is 2 pi over 60 darab 2 pi. You have to convert this into radian per second lah, okay? So you should get the value of 20 pi radian per second. Plus, so we also have the final angular velocity, which is equal to 300 rpm. Again, we have to convert this into radian per second. So this is 10 pi radian per second. And then it gave us the time interval, which is in 6 seconds. Okay, so this one is just basically using the formula, which is equal to omega naught plus alpha t. Okay, so kamu substitute jala the values we have converted into the SI unit. So you should get the angular acceleration to be equal negative 5.236 radian per second square. So why is it negative? Sebab dalam soalan dia sudah mention that it is decreasing at a constant retardation. So retardation means it is basically in linear motion is basically it is known as deceleration lah. Okay. Okay, what else? Oh, question B. We have to find the number of revolutions that the body has turned in 6 seconds. Okay, so number of revolutions, kita boleh guna formula apa? Kita boleh guna formula theta equal to omega naught t plus half alpha t square. Okay, so this is basically this similar to our chapter 2, but this one is just for rotational motion lah. Okay, so this is 20 pi, then this is 6 seconds plus half, negative 5.236, and then this is 6 square, so this is equal to 282.743 radiant. Okay, so that is the angular displacement, but then we have to convert this into revolution sebab dia minta in terms of revolution lah. So one revolution is equal to 2 pi radian. So this one we are gonna times it with 1 over 2 pi to get dalam revolution lah. So this is 45 revolutions. Okay, and then the final questions, we have to find the extra time needed by the body to come to a stop if it continues to slow down at the same rate. So if it continues to slow down at the same rate, this is just we are gonna use the formula omega naught plus alpha t. So dia cakap at this stop and then go decreasing at the same rate, so kita akan guna the velocity, the angular acceleration yang tadi lah, 5.236 t, which is equal to 6 seconds. So it needs another 6 seconds lah untuk dia stop comes to a stop. Okay, right, so that is basically the solution for question number 2.